Hi students, in this session we will discuss a question from exercise 10C from the chapter Electromagnetism. The question is, the diagram shows a fixed coil of several turns. This is the diagram and this is the fixed coil of several turns connected to a center zero galvanometer G. This is the galvanometer. The coil is connected to this galvanometer and a magnet NS is which can move in the direction shown in the diagram. This is the magnet and the direction of the motion of the magnet is shown in this way. The part A of the question. Describe the observation in the galvanometer if the magnet is moved rapidly. If this magnet is moved in this direction rapidly, what would be the observation in the galvanometer? Initially, the needle of the galvanometer is showing 0. That means there is no deflection. Now you must observe what happens to this galvanometer needle when the magnet is moved rapidly. Second part is the magnet is kept stationary after it has moved into this coil. This magnet, after it has moved into this coil and it is kept stationary, that time what would be the galvanometer reading? You must observe the galvanometer. Third part of the question is, the magnet is then rapidly pulled out of the coil. This magnet, which was kept stationary inside this coil, now it is pulled out from this coil. That time, what is the observation of the galvanometer? That is the part A of the question. In the B part of the question, they are asking you how would the observation in one of part A change if a more powerful magnet is used. In this case, if you are using a more powerful magnet, when the magnet is moved rapidly, what would be the observation? This is the question. This is from exercise 10C. How will you answer this question? In the question, they have given you a coil and this coil is connected to a galvanometer. Galvanometer G. What is this galvanometer? Galvanometer. Galvanometer is an instrument or a device which is used to measure electric current. You can measure small values of current using this galvanometer. In the diagram given, the galvanometer shows the needle of the galvanometer is at the center, which shows 0. This 0 indicates this needle is exactly at the center and there is no deflection of this needle. That indicates there is no current passing through this coil. Whenever a current passes through this coil, this needle will deflect. If the current flow through this coil is in this direction, that means in the anti-clockwise direction, the needle of the galvanometer will deflect towards right because the current is flowing in the anti-clockwise direction through the coil. But if the current is flowing in the opposite direction means this is clockwise direction. If the current is flowing in the clockwise direction, this needle will deflect towards left. This is the clockwise direction. The galvanometer shows no deflection when there is no current. And when the current flows in the clockwise direction, this is the clockwise direction, the deflection will be towards left. And when the current flow is in the anti-clockwise direction, and this is the anti-clockwise direction, then the needle will deflect, needle of the galvanometer will deflect towards right. In the question, you can also see a bar magnet. Say this be the bar magnet. Bar magnet, this is the north pole of the magnet and this is the south pole of the magnet. If you have a magnet, the magnetic field around it can be represented using the magnetic field lines. The magnetic field lines are always from the north pole to the south pole of the magnet. These are the magnetic field lines. Towards the pole, the field will be more. These are the field lines. The arrow mark is always from the north to the south. These are the field lines. And this bar magnet, this is the bar magnet, and if this bar magnet is moved towards, in the diagram they are saying this bar magnet is moved in this direction towards the coil which is kept here. This is the coil, and this coil is connected to a galvanometer. When this bar magnet is moved in this direction towards the coil, what happens to this magnetic field lines? This magnetic field lines will enter the coil, and when this magnet is moving inside the coil, when it is moving rapidly, there is a change in the magnetic flux. We know according to Faraday's law, whenever there is a change in the magnetic flux linked with this coil, an EMF is produced and an induced current is set up. And this induced current which is set up in the coil can be measured using this galvanometer. In the given question, this coil is fixed and this bar magnet is moving. Only when this bar magnet is moving, as this coil is fixed, only when the bar magnet is moving, there will be change in the magnetic flux. And according to Faraday's law of electromagnetic induction, only when there is a change in the magnetic flux an induced current is produced. Therefore, you must remember, only when the bar magnet is moving, there will be deflection in the galvanometer. When this bar magnet is stationary, there will be no deflection in the galvanometer, because then there will be no induced current. What is the direction of the current flow in this coil? To find out the direction of the current flow, there is a law called Lenz's law. According to this law, the direction of the induced current in this coil will always oppose the cause which produces it. As per this Lenz's law, the polarity of this phase must be north pole. The polarity of this phase means the phase which is closer to the magnet, or the phase which is facing this bar magnet. This phase should have the polarity N. Why? Because this is also N. We know like poles will repel each other and unlike poles will attract each other. The magnet is moving in this direction, so that this polarity will try to repel it. This face of the coil, which is facing the magnet, is having the north polarity according to Lenz's law. The magnet is moving in this direction, therefore this north polarity will repel this movement. If this is north polarity, if it is having north polarity, the direction of the current flow will be anti-clockwise. You put an arrow mark at the tip of N, and that will give you the direction of the current flow. This shows anti-clockwise direction. If it is south polarity, you must put the arrow mark at the tip of S, then that indicates clockwise direction. Here in this first case, the polarity is north polarity, north pole, therefore the direction will be anti-clockwise. This is the anti-clockwise direction. The direction will be, direction of the current flow will be anti-clockwise. The current flow through the galvanometer will be in this direction. Therefore, the needle of the galvanometer should deflect towards right. The current flow is in the anti-clockwise direction. When the magnet is moved and kept stationary inside this coil, there will be no deflection to this galvanometer because it is kept stationary and there is no change in the magnetic flux and hence no induced current. Therefore, the deflection of the galvanometer will be 0. What happens if this bar magnet, which is inside the coil, now it is pulled out of the coil? This is the bar magnet and the magnet is moving away from the coil. There is some motion, therefore induced current is produced. And what is the direction of the induced current formed? The magnet is moving away from the coil. Therefore, the side which is facing the magnet, this face, what will be the polarity? Here, the polarity, the magnet is moving away. Therefore, it should oppose that motion. It should attract, isn't it? Therefore, the polarity here should be south. This is the north pole of the magnet. According to Lenz's law, it should always oppose, the induced current will always oppose the cause which produces that. If this phase is south pole, what will be the direction of the current flow? If it is south pole, the direction will be always clockwise. Clockwise direction. Clockwise direction means the current should flow in this manner. The deflection of the needle of the galvanometer will be towards the left as the current is flowing in the clockwise direction. Therefore, the answer for the question is part A. The first section, the answer is a deflection is observed in the galvanometer towards the right when the magnet is pulled towards the coil. In that case, the galvanometer will show deflection towards right. In the second case, the deflection becomes 0 because the magnet is stationary, it is not moving. The third part of the question, when the magnet is moved away from the coil, when it is pulled out of the coil, the deflection again occurs but in the opposite direction. This is the answer for the part A. What is the answer for part B? If you are replacing that magnet with a strong magnet, definitely the deflection will be more because the magnetic strength will be more. Then the deflection is increased if you use a more powerful magnet. If you increase the number of turns in the coil, then also the current produced will be more and the deflection will be more. If you are using a strong magnet also, the current produced will be more and the deflection will be more. I hope you understood the session. If you have any doubts in this question, please contact me via email pjscracker@gmail.com. And if you like this video, please share it with your friends. Thank you.